Hi folks, my name's Steve Watts. I lead the Office of the CTO, and that includes our research division, our emerging technologies division, and our open source program office that handles our community strategy, specifically for foundations and technologies like this. So I just wanted to start with how our customers see the opportunities and challenges for the future. Typically, when I talk to one of our customers, the conversation goes a little something like this. Hey, Steve, I'm super interested in generative AI or using inferencing in traditional clusters or at the edge. However, here's my challenge. I've got application and infrastructure investments on Google, AWS, Azure, my bare metal deployments and clusters in my own data center, and sometimes for some of our customers, they're trying to deploy to fleets of devices out at the far edge. And what they'll then say next is, look, here's the challenge for each of these deployments or infrastructures. I've got a separate development stack and tool chain and a separate set of management tools for each of these. And trying to coordinate and have different teams manage all these different things with different stacks and technologies is just so complex, and it's so hard to move. And then at the same time, when I'm trying to go off these incredibly scarce skills on generative AI and try to find the Venn diagram overlap of folks that understand how to manage and deploy to these infrastructures and know these AI skills, it's so hard. And then at the same time, I'm finding that industry standard servers that are like x86 aren't really providing me the performance that I need. And so I'm increasingly offloading computation to increasingly exotic architectures that include RISC-V. And so how can you help me with all of this? Because these are problems that I need to solve in the future. So Red Hat is a hybrid cloud company that uses an open source development model. So that sounds a bit buzzy, so let me kind of explain what I mean by this, right? Which is that we provide a single development model and a single management model that provides a platform abstraction across all those infrastructures that I just mentioned, so that they can have just one way of developing and managing things and be able to deploy to all these different infrastructures, including the far edge. And so I want to talk a little bit about what this experience or solution looks like in real life. All right, so I'm just going to tell a story. You've got Sally over here, and Sally is the developer, and you've got Hemant over there, and Hemant's responsible for platform engineering or operations. And so what Sally will do is she'll use Red Hat OpenShift AI, which is her way of sort of building and deploying and configuring AI-infused applications. And she'll pull up Jupyter Notebook, inside that build and train her model, sign it, containerize it, commit it to Git, and she's done with her first part of the deployment lifecycle. Hemant can then come over there and use Red Hat Advanced Cluster Management and use the GitOps deployment methodology to now choose to deploy to either a traditional cluster on a public cloud or bare metal on-premise on Red Hat OpenShift, which is our enterprise Kubernetes distribution running on top of Red Hat Enterprise Linux. Now, this already runs on top of ARM and x86. But now the work to do is to get this working on RISC-V. So this is where the RISC-V enablement comes in to solve that problem for our customers. Or Hemant could then basically push that Git URL to a fleet of far edge devices and say, hey, pull this application down and deploy it on these far edge devices. And that's where she would maybe do a computer vision inferencing engine that's integrated into a specific application. And I'll actually show you sort of a demo that we're doing towards this at the end. But in that same space, we have Red Hat Device Edge, which runs an upstream technology called Microshift, which is a very pared down version of OpenShift or Kubernetes for resource-constrained devices, right? And again, this runs on top of RHEL, and so we need to do, it's got the ARM and x86 enablement, we've got to do the RISC-V enablement at the bottom, right? And so that's sort of how we would address all of this for that customer. Single development story, single management story. They're able to leverage their generative AI models, whether they're building traditional applications or ones that are using new workloads. So how do we get here? So we have been enabling RISC-V in Fedora since 2017. So you here see a couple of examples that run Fedora, so the Sci5 server, the Beagle board, the Milk5 server. If any of you are interested in contributing towards Fedora enabling RISC-V, there's a gentleman here, Fu Wei. He's here at the conference. Very active networker, but he's the guy in this community for us. So have a chat to him. But this is where we start, because Fedora is our upstream for RHEL, right? So we use an open source development model as we produce Red Hat Enterprise Linux, our product, and OpenShift. So everything that gets into RHEL starts in Fedora. So this is where our work to enable RISC-V to get it ready for an enterprise Linux distribution starts. And what we've learned thus far is we've still got a couple things to solve. So one, maturing the RISC-V ecosystem. So things like compilers and tool chains, various different programming language support, kernel drivers, firmware. These are all things that we need to add to Linux around, beyond just the core operating system on top of it. We need to basically, as a community, start to understand what things should be default, what things should be optional, and in terms of what an enterprise Linux distribution or a server class system is, and then how we work together to solve those problems. And most specifically, being able to sort of really understand what should be default, what should be optional to allow us to focus and move forward. So to this end, we've started some work in this space. So CVA6 is a vendor-neutral profile from the Open Hardware Group. You can go check this out at their booth. They've got this really cool demo which shows how you can configure it on an FPGA, boot up Fedora, play Tetris on it. But specifically, what we've done is we've put this into Fedora so that when you can push a change into Fedora and you kick off the CI, it will actually test against this vendor-agnostic profile as a target. And this is really important for repeatable, consistent builds so that we make sure that as Fedora moves forward, we're not diverting from the way RISC-V is going. And if you would like to know more about this, Brian Harrington, or as he's more colloquially known as Redbeard, because he's got a gigantic red beard, he's sitting right over there. He's the guy to talk to. He would love to talk to you more about helping out on this project. So the next aspect is building the broader ecosystem around RISC-V. So I mentioned a little bit before about the tool chains, the compilers, the language support, all the things that we need to build around this. We feel that the RISE Foundation is a really important and useful way to go about this. We can use open source best practices, meritocracy of ideas, but specifically collaborate. So what we've discovered is if 6 of us are all trying to solve the same problem, that we can solve it in one place in open source and then take the other streams of effort for the other 5 activities and go solve 5 other problems, right? So there's the ability to sort of drive efficiency over there, as well as get to consensus on what should be default, what should be optional, as we start to define what an enterprise Linux distribution is. So in this space, Jeffro Osir-Mixon, who's right over there, is the person to talk to. He does a lot of our coordinating around the RISE Foundation. So chat to Jeffro if you want to learn more about this, or me if you find me in the hallway. So just to summarize where we're going in our community engagements, obviously we're involved in RISC-V International itself, RISE, and the Open Hardware Group, sort of sum up our broader community strategy in this space. All right, so what I wanted to do is just close with a research project that talks a little bit about how we're trying to pull all of this together to solve that specific solution scenario of being able to do inferencing out on the far edge, which is a very popular use case that we hear from our customers. And so one of the projects that we've created to be able to rapidly iterate in this space is Dynamic Infrastructure Services Layer, which is an abstraction across different FPGAs that allows you to very easily, sort of in one place, design the system, configure the FPGA. It also has capabilities that allow you to connect to sort of remote components. So this might be like a little edge device that, in this case, is a little camera. We've got a specific demo here that I'm going to show you, which is like a Nest doorbell, like a little wireless doorbell to figure out who's at your door. And so the demo that I'm going to show you is little computer vision. So it's going to configure the FPGA, configure the soft core, which is going to got the piece that does the inferencing on it, and then you're actually going to see it's going to send the image, and the inferencing piece is going to figure out whether it's a person or not a person. So if it's not a person, it's green, and if it is a person, it is red. So let me go back. Can we start it? Okay. You can check this out at research.redhat.com. There's a link on this that'll have a full video. It's also, we've got multiple videos on YouTube that will sort of demonstrate how this works. But what you would have seen is in the terminal window, you'll see the FPGA being configured. You'll see the application being able to be loaded on the soft core just in a matter of minutes. And then you'll be able to see the progress. It would have shown you like a little Red Hat logo that would have turned green because that's not a person, and when there's an actual live person, it would have turned red. So just a little very binary, simplistic version of inference against the model. If you would like to learn more, check out research.redhat.com, next.redhat.com, which is our emerging technology space, or community.redhat.com. We're very excited about RISC-V and would love to talk to you more about it. Thank you very much.